Ladies and gentlemen, welcome back to Geometry. This is Chapter 12, Lesson 4. We are looking at a volume, the volume of a prism and the volume of a cylinder. Volume of a prism, we just take the area of a base. Now, very important, capital B is the area of a base times the height of the prism. The height of the prism is the distance between the two bases. Now with a rectangular prism, it really doesn't matter which side you use as a base. Any two opposing sides in a rectangular prism. But otherwise, if it's any other type of prism, it's the two shapes that are parallel and opposite each other. Alright, so volume of a cylinder is basically the same thing. Take the base times the height. But in a cylinder, the base is always a circle. So we can make this a little more specific and say it's pi r squared times the height, because the base is a circle. So, now one thing to know about is Cavalier's principle, and he discovered that if the prisms have the same height, if you have an oblique prism, if they have the same height and the same cross-sectional area, that means you can cut it somewhere in between and that's the same area. Oh, that wasn't supposed to happen. Then they will have the same volume. So if it's oblique, you still just find the area of the base and multiply that times the height. And that's Cavalier's principle. Alright, here's a quick example for you. Here we have a diameter of 9, which means the radius is going to be 4.5, and a height of 5. So volume is pi r squared h, so 4.5 squared times 5, and there we go. 318.1, and that's all the fun we're going to have today. See you in the next lesson.